Hello students, in this video we are discussing problems on Z transforms. In the last video we have discussed properties and some standard functions of Z transforms. Using those properties and standard functions we can solve the problems easily. Before solving problem, let us go through the list of Z transform of standard function we have here. Z transform of 1 is Z by Z minus 1. Z transform of k power n, Z by Z minus k. For example, you can write Z transform of 3 power n as Z by Z minus 3. And Z transform of n is Z by Z minus 1 whole square. Z transform of n square, Z square plus Z divided by Z minus 1 whole cube. Z transform of n cube, Z cube plus 4Z square plus Z divided by Z minus 1 whole power 4. Z transform of k power n into n equal to kz divided by Z minus k whole square. So next, Z transform of k power n square. This all damping rule result with the n square n cube formula. Kz square plus k square z divided by Z minus k whole cube, and k power n into n cube Z transform is kz cube plus 4k square z square plus k cube z divided by Z minus k whole power 4. And very importantly, Z transform of cos n theta is Z into Z minus cos theta divided by Z square minus 2Z cos theta plus 1. Z transform of sin n theta is Z in sin theta divided by Z square minus 2Z cos theta plus 1. So keeping this all formula, remembering this all formula, you can solve the problems very easily. So let's begin with the problem. These are very important problem for exams also. Find Z transform of the following: cos h n theta, sin h n theta, cos h n pi by 2 plus theta. Here I'll do the problem of cos h n theta. Similarly, you can work on sin h n theta, cos h sin n pi by 2 plus theta. So let me take the function first, cos h n theta. Let un is cos h n theta, can be written as e power n theta plus e power minus n theta divided by 2. Therefore, Z transform of cos h n theta is 1 by 2 by linearity property. We'll keep 1 by 2 out. Z transform of e power n theta plus Z transform of e power minus n theta. Next, we take this is in the k power n format, like Z transform of e power theta power n plus Z transform of e power minus theta power n. So we know the result is Z transform of k power n is Z transform of k power n is Z by Z minus k. So using result here, we get Z transform of cos h n theta, Z transform of cos h n theta is 1 by 2 Z by Z minus e power theta plus 1 by 2 keeping out, Z by Z minus e power minus I theta. So applying k power n form to both. Then we get Z is common out, let us take out Z by 2, and we take LCM Z minus e power theta and Z minus e power minus theta, and here we get Z minus e power minus theta plus Z minus e power theta. So what we get from this? Z by 2, 2Z minus common out, e power theta plus e power minus theta divided by, we have Z square minus Z e power theta plus e power minus theta, and e power theta into e power minus theta is 1. Then we can simplify this as z by 2, since this can be written as by multiplying 2 and divide by 2, this can be written as cos h theta. So therefore we get here it is 2z minus 2 cos h theta divided by, same way in the denominator, multiply and divide by 2, we get the result as z square minus 2z cos h theta plus 1, and 2 is taken common, gets cancelled, we get the result z transform of cos h n theta as, so you are operating z transform on nth term, we get purely z term, z into z minus cos h theta divided by z square minus 2z cos h theta plus 1. Similarly, you can prove the other result, you can obtain the result z transform of sin h n theta, and one more problem. Let's solve another problem here. We have two problems. So firstly, I'll take first one, sine 3n plus 1. So let us take, this is un. So now you find the transform of this. Before that, we simplify this. We can't apply directly the transform of this type of function. We need to simplify. So that can be written as like sine a plus b. Sine a, sine 3n cos b, cos phi, plus cos a, cos 3n, sin phi. Now you can apply the z transform on this. So now z transform of this un will be, I'll keep this cos phi, sin phi are constant separate. So cos phi, z transform of sin 3n plus sin phi, z transform of cos 3n. Now we know the formula of z transform of sin n theta is z sin theta divided by z square minus 2z cos theta plus 1. And we know that z transform of cos n theta is z into z minus cos theta divided by z square minus 2z cos theta plus 1. Therefore, substituting here theta is 3, here also theta is 3. In the formula, we get, so this is u bar z. The transform of un is u bar z. I'll keep cos phi as it is. And z transform of sin 3n. So where theta is 3, substituting here, it gives z sin 3 divided by z square minus 2z cos 3 plus 1. Similarly, other one, keep sin 5 as it is. Next, z sin z into z minus cos theta, z minus cos 3 divided by z square minus 2z cos 3 plus 1. So now again a denominator is same. Let us simplify. So z square minus 2z cos 3 plus 1, in the denominator of both the terms are same. So we can take z common out. You can write cos 5 sin 3 minus sin 5 cos 3. So remaining is plus z square sin 5. Here plus z square sin 5. So now this is in the form of cos a sin b minus sin a cos b. So it can be written as sin a minus b. Sin a minus b. Therefore sin, we get sin 2 this and plus z square sine 5 divided by z square minus 2z cos 3 plus 1. So this is z transform of what they given, sine 3n plus 5. The second one is cos n pi by 2 plus pi by 4. Second problem. We have the second problem is cos n pi by 2 plus pi by 4. It is un. So we simplify this cos a plus b. Cos a plus b can be written as un can be simplified as cos a cos b cos n pi by 2 cos pi by 4 minus sin n pi by 2 sin pi by 4. We know that cos pi by 4 and sin n pi by 4 both are equal to 1 by root 2. Therefore, this is equal to 1 by root 2 of cos n pi by 2 minus sin n pi by 2. Now, z transform of this un is 1 by root 2 z transform of cos n pi by 2 minus z transform of sin n pi by 2. So here theta is what, comparing with the standard result, theta is pi by 2 in both the cases. Substituting this theta is pi by 2 in our standard formula, 1 by 2 z into z minus cos theta, so cos pi by 2 divided by z square minus 2z cos theta cos pi by 2 plus 1. Next minus z sin theta, z sin pi by 2 divided by z square minus 2z cos pi by 2 plus 1. So 1 by 2 is common. Now since cos pi by 2 is 0, cos pi by 2 is 0, cos sin pi by 2 is 1. So you can simplify this as, since both the denominator is same now, this become 1 by 2, z square plus 1 is remaining in the denominator because cos pi by 2 is 0. And numerator of first term is z square minus z. So this is our result. The next problem we have z transform of 2n plus 5 sin n pi by 4 minus 3a power 4. So let us take this equal to z transform of 2n plus z transform of 5 sin n pi by 4 minus 3a power 4 z transform of 1. And you can also keep 5 out, 2 out. See here, we have, it is not a n term, it's completely constant. We are operating z transform on only n term. Any constant present that we keep out, we consider 1 is remaining, we can operate z transform on 1. So now you can obtain the result as 2 keeping out z transform of n. So it is z by z minus 1 whole square. Next 5 keeping out z transform of sin n pi by 4. It is n theta format, pi by 4 is theta. So therefore z sin pi by 4, z sin theta divided by z square minus 2z cos pi by 4 plus 1. Next minus 3a power keeping as it is. Z transform of 1 is z by z minus 1. So now I can write finally the result as 2z divided by z minus 1 whole square. Next 5z and sin pi by 4 cos pi by 4 having the same result 1 by root 2. So I'll take divide by root 2 and 1 divided by z square. This also 1 by root 2. So you can do that, this 2 and root 2 gets cancelled, remaining root 2. So minus root 2z plus 1. Next finally 3a power 4z divided by z minus 1. So this is how you can obtain the result. So we have one more important problem here. So that is z transform of 1 by n factorial. We have to prove this as e power 1 by z. Hence find the result z transform of 1 over n plus 1 factorial and z transform of 1 by n plus 2 factorial. First of all, we don't have any factorial term in our standard result. Suppose if the case arises like this, we use what? The definition of Z transform. So we know that Z transform of Un. Z transform of Un is what? Summation n equal to 0 to infinity that Un z power minus n. Here in our problem Un is 1 by n factorial. So that is summation n equal to 0 to infinity 1 by n factorial z power minus n. So now just we expand. Whenever we are using the definition, we expand the series. So by expansion, this gives us what? 1 by 0 factorial, it is 1. Z power 0 is 1. Then plus, you can write this as summation n equal to 0 to infinity 1 by z power n divided by n factorial. Then it's easy to obtain the result. Next, n equal to 1 gives 1 by z by 1 factorial. N equal to 2, 1 by z whole square by 2 factorial. Likewise, it will continue till infinity. It is in the form of 1 plus x by 1 factorial, x square by 2 factorial, and so on, can be written as by Taylor's expansion or Maclaurin's expansion e power x. Therefore, the above result become z transform of 1 by n factorial can be written as e power 1 by z, because in the place of x we have 1 by z. This is what the proof. And they're asking extra result, we have to find 1 by n plus 1 factorial. So you can use this result using the shifting rule. Shifting rule, z transform of un plus 1 is z u bar z minus u naught, and other shifting rule we need here un plus 2, that is z square u bar z minus u naught minus u1 z power minus 1. Now what you can do here to find the result using this one, let us consider un plus 1 is equal to 1 by n plus 1 factorial. Then from this you can write un is 1 by n factorial. So u bar z is z transform of un, that is z transform of 1 by n factorial, that is 1 by z. We have this result now. Therefore, according to the shifting property, z transform of 1 by n plus 1 factorial. So if you consider this un plus 1 is n plus 1 factorial in the denominator, z u bar z, using the result this, u bar z is what? E power 1 by z minus u naught, where un is 1 by n factorial. What is u naught? 1 by 0 factorial, it is 1. Therefore, minus 1. This is the z transform of 1 divided by n plus 1 factorial. So, similarly, z transform of 1 by n plus 2 factorial. If you take un plus 2 is 1 by n plus 2 factorial. Then un is what? 1 by n factorial. Then u bar z e power 1 by z. So according to the result we have here, z square u bar z nothing but e power 1 by z. U naught means 1. U1 is also 1. because 1 by 1 factorial, it is also 1 into z power minus 1 can be written as 1 by z. So this is the result of z transform of n plus 2 factorial.